Welcome back to the channel and welcome to the shop. I'm working on the Davis crankshaft here. I'm going to get it cleaned up a little bit so I can get it taken to a machine shop and get it straightened. It is bent. I don't think it's bent too bad, but it just needs to be straightened, and I'm not going to attempt to do it by myself because that's a real art to do that. And this crankshaft is at least 125 years old. Davis started building this design engine in 1895, and the tag on this engine has a date on it that says 1900, so it's at least 125 years old. So I'm going to take it in, let the professionals do it. I'm just going to clean it up here a little bit and get any burrs off, just get it polished up a little bit and try to get that gear off. This is quite a project, but just gonna get it done right and then get back on the 8-horse mogul. Going to start here by getting that key out, or what's left of it. That's the key from the first flywheel, and you'll remember that flywheel came off pretty easy. It's because if you look closely at that key as I start driving it out here in a little bit, it is collapsed. I was able to get it drilled and then collapse it, and that released it from the flywheel hub and let it come off real easy. So I'm going to take this punch here and hammer and just slide it out of that groove so I can get the groove cleaned, the keyway groove cleaned, and you can see how collapsed that is, and it's just a shell of a key. So anyway, so we'll get that out and then continue on. Taking a file here and just knocking any burrs or anything off on this journal here. This is one of the main bearing journals, so I can slide that gear off. Hopefully I can get it off there without any trouble. I don't think it's on there very tight, but I'm just going to take my time here and get it cleaned up so I don't have any trouble. Got to be careful with this crankshaft. It's real easy to bend them. They're just mild steel, and if you look real close on the crank throw there, you can see the trip hammer marks from where it was forged. So it's kind of neat. Also, another neat thing to think about is the time period when this was built. Probably the people that built it were either in or had a real close relative that was in the Civil War. So it's kind of neat to think about stuff as you work on these old engines like that, who maybe had touched them the last and put the parts together. So I tapped it with the punch there. It doesn't want to come off, so I'm just going to put some PV Blaster in here and go to a little different method here, but just slow and steady on this. Go ahead and clean the rest of this shaft up because that gear has to come clear out off of there. So just cleaning any burrs up and just do it right, and then I won't damage the crankshaft anymore. So just keep working here and we'll see if we can get that gear to come off. Going to go with the gear puller here. This gear isn't on there very tight. I just don't want to beat on that crank anymore, so we'll just get that gear pulled off here. Should be pretty easy, and there it is. It slid right off, and that key in there is rather interesting. You'll be able to see it here in just a minute, but it's not even in a keyway on the crank. There's just a flat that's been milled on the crank and a real skinny key that keys that timing gear to the crankshaft. So dig that out here. You can see it. it's just a real skinny key. It's just things on this engine you don't see on modern engines, or even in some of the engines that I do that are pretty old. It's just some really early development stuff going on here. So get this side cleaned up, and then we'll be ready to get it taken in and get it straightened. Okay, going to repeat the process on the other side of the crank, and I've got a wire brush here. It's a brass bristle brush and some PV Blaster. I'm just going to clean up any rust or grease or anything that's on this crank, and go ahead and get this side cleaned up. And here I'm using a piece of tool steel to clean out this keyway groove. Just fit just perfectly, and the crank throw has some teeth marks in it, like a wrench or something was on it, so I'm going to have the shop probably grind that. I'm just going to take off the ridges and the actual grooves in there. They don't need to be removed because they'll just hold oil, but I just don't want any sharp edges on it, so I'll have it ground. So we'll get it off to the machine shop and see how they do. Here's a picture of the crankshaft after it was straightened. It wasn't bent in the throw of the crank. It was bent out about where those bolts were, and bent up on each side like those bolts kind of represent. It was about 10 thousandths on one side and about 12 thousandths on the other side. They were able to get it straightened within a couple thousandths, and that's pretty good. And I just didn't want any more work to be done to this crank because it might have damaged it. I didn't know if there was any flaws or anything in it. So anyway, that's kind of how that works. It was a good job they did on straightening it. I'm glad that they were able to get it within a couple of thousandths, and should run pretty true now. Moving on to the piston and piston rings. Gonna put the GoPro in time lapse here for a couple of clips, and kind of show how I get the rings off of here. Pulled it out of that WD-40 solution, and I'll start working on it. You can kind of see how much smaller this piston and wrist pin are compared to the 8-horse Mogul piston in the background there. Just a lot smaller engine. But we'll get to pulling those rings off, and then I'm going to have to order rings for this engine as well. I'm going to show you my method for getting these rings off. I use a block of wood, and I start tapping on them and soaking them in the WD-40, and that just tapping on those rings will loosen them up. And if you go prying on them and try to force them with screwdrivers and hammers, steel hammers and stuff, you're just going to break them, because these rings are cast iron and they're very brittle. So I've never broken any rings with this method. It's just the method I use. I just go around and tap each one, and it's amazing how quick they start coming loose. Once they're all loose, then we'll start pulling them off of the piston. Along with my method for loosening the rings, I have my own method for taking them off. You can use a set of ring pliers and try to pull them off. The problem with that is they're very wide. These rings are 3/8 of an inch wide, and you'd have to make some custom end piece for a set of pliers to pull them off. So what I do is I put zip ties around the ring, and you see me feeding one in there gently, and I'll work that around and then put a bunch of zip ties on there, and then I can just slide the ring right off the top. What I'm doing here is moving that one clear around the ring. It's really not what I want to do, I'll end up changing that here in a minute, because as you can see, that ring is very tight now, and I'm afraid I'm going to end up breaking it. So end up probably just moving that back, put them all on at the same place there, right next to the start of the ring, and then slide them around a little later. But if you take your time, you can get them off and not break them. I have not broken a ring to date yet, so in the years that I've done this, and I've always just kind of used this method. It works really well. And here I am working those zip ties around. I used 6 of them. That will make that ring slide off real easy. Sometimes I use heavier zip ties for bigger rings, but these little 4-inch rings, these smaller zip ties work just fine. So I've got them evenly spaced around. You can kind of see I'm just working them around one by one. And it basically pulls the ring mostly out of the groove. So that's what we're looking for. So just keep working them around here, and then we'll be able to get them positioned where we want them and get the ring off of there. Here's a close-up of all those zip ties spaced around there, and we'll see. I can start to get the ring moved up. I'll just pry on it a little bit to get it started gently, and you'll see that it'll just come right off the top there, slide right over those zip ties, and come right off the piston. So I'll end up doing that with the other 2, and then we'll take a little closer look at them. Here's a quick view of all 3 rings removed from the piston. Process went pretty good, and I didn't break any of the rings. Here's a close-up of the piston, and it shows that there's a pin in each one of these ring grooves, and that holds the ring in position so that it doesn't try to spin around the piston as the piston's moving up in the cylinder. That was quite common on these engines. You'd actually get kind of a rifling effect in the cylinder from these rings, and it would start spinning as it was running and wear them out. So these register pins or locating pins keep that from happening. And here's a view of one of the rings. You can see that slot there that goes around that pin that I showed just there just a little bit ago. That's just how it kind of locks into place. The new rings I get won't have that in there. They'll be flat on the ends, so I'll have to put some sort of groove or slot in them to go around those pins. So that does it for this video. Thanks for watching, and like and subscribe if you like the channel, or if you just want to see what I'm going to be doing next. Next video, I plan on getting back on the 8-horse mogul and putting the mixer together. So see you in the next video.